Hi, we're Team P21603, a multidisciplinary senior design team in the Kate Gleason College of Engineering. We're working with the AM Print Center at RIT to create a continuous carbon fiber 3D printer extrusion head. Our main goal is to design an extruder that can reliably print a fiber-reinforced thermoplastic composite on a traditional 3D printer. Along with that, we want to create an extruder that any 3D printer enthusiast can construct themselves. And our final goal is to hopefully bring some ideas into how this extruder can be integrated and used on a 5-axis printer.
We are on track to deliver a final prototype that meets temperature and speed requirements for a high-temp carbon fiber extrusion head. We plan on integrating our modular design with an existing 3D printer frame, using open source software to deliver a fully functional carbon fiber printer.
Our system will include 3 feeds in total. 2 for both the thermoplastic feeds, which will be mounted on the frame via bolt and drive. The other feed channel will be for the fiber feed, which will be using a direct drive mounted on the extruder.
Due to the increased complexity of utilizing 3 feeds over the general 1 or 2, we have had to design and produce a new heating block that will be able to merge the fiber and thermoplastic feeds as they go through.
What makes this extruder truly unique over a traditional extruder is the requirement of a cutting system in order to cut the fiber. Our team has found that a solenoid and cutting blade combination is sufficient to cut the fiber effectively and allow continuous printing over a 24-hour period.
For control, we've decided on SmoothieWare using a Big Tree Tech board. This program is not only among the highest performance 3D printer software available for free, but also allows us to add modular components to the control block without code changes, making the product much easier to pick up and add to in the future.
Our team's biggest challenge has been the COVID-19 pandemic. We've had to be flexible, switching between online and in-person meetings frequently, and have continued making steady progress towards our goal. Both labs we've used have been significantly reduced in capacity due to COVID-19, making it difficult to create a consistent schedule to work in person on this printer.
Our expected result is a working prototype for a 3D printer extrusion head capable of printing with continuous carbon fiber in a thermoplastic matrix. Our goal is to develop an open source model for engineers to build and expand upon. Although we are designing for a 3-axis printer, the ultimate goal of this design is to be implemented into a 5-axis system.
We'd like to thank Dennis Cormier of the RIT AM Print Center for his time spent assisting us in planning for this project, as well as his dedication to helping us acquire critical components for the extrusion head. We'd also like to thank our project guide, Bill Nowak, for helping us through our project.